On the morning of June 10, 1891, a woman named Mrs. S. Culp was breaking coal for her household stove in Morrisonville, Illinois. She swung the hammer. The lump split cleanly in two. And from the center of it fell a chain. Gold. Roughly 10 inches long. The link small, uniform, and closed, each ring sealed without a gap, without solder, without any visible mark of joining. The two ends of the chain were still embedded in the coal, one in each half of the broken lump. The impression of every link was pressed into both halves like a casting mold. The coal had not cracked along an old fracture. It had split fresh. The chain had been inside, sealed in material that formed during the Carboniferous period, approximately 300 million years ago. Culp held it in her palm for a moment. Then she showed it to her neighbors. Her pastor. The editor of the local paper. The following morning, the Morrisonville Times printed a notice 9 lines long. 9 lines. For an object that should have changed everything. It changed nothing. The notice ran once. The chain's location today is unknown. And for the next 130 years, nobody connected what Culp found to the 5 other people, in 5 different states, across 7 different decades, who split open a lump of coal on an ordinary morning and found the same impossible thing inside. This is their record. The earliest chain was not Culp's. It was found 23 years before her, by a man who was 600 feet underground. In the autumn of 1868, a crew expanding a lateral gallery in a deep anthracite mine near Wilkes-Barre, Pennsylvania, broke through a coal wall. One of the miners, a man named Elias Schott, noticed a glint in the freshly exposed face. He pried the seam apart with a chisel and extracted a length of fine chain approximately 8 inches long. The links were so small that at first glance the object looked like woven wire. Under a hand lens, each link was distinct, a tiny closed ring interlocked with its neighbors in a pattern that repeated without variation from one end to the other. Schott brought it to the surface. The mine's superintendent sent it to a professor of chemistry at Lehigh University, 40 miles south. The professor examined it over several days and wrote a letter stating that the metal was a gold alloy of a type he had not previously encountered, and that the workmanship was unlike any known goldsmithing tradition, European or indigenous. He placed the chain in the university's mineral collection. By 1890, it was gone. The collection log shows the entry, a fine gold chain, anthracite inclusion, Luzerne County, but no checkout, no transfer, no accession note explaining where it went. The entry simply stops. 11 years after the Wilkes-Barre chain, a fireman named Hiram Beckley was breaking anthracite to feed a colliery steam engine in Schuylkill County, Pennsylvania. A chunk of coal split under his hammer. A loop of metal fell onto the iron grate. Beckley picked it up before it could slide into the fire. It was a chain formed into a closed loop, roughly 6 inches in circumference. The links heavier and wider than what would later be found in Morrisonville. And at one end, a clasp. 2 interlocking hooks that allowed the loop to be opened and closed. A clasp implies jewelry. Jewelry implies a wearer. Beckley took it to a photographer in Pottsville who made a single image of it laid against a white card. That photograph survived. It was included in a County Historical Society donation in 1923 and is still in the Schuylkill County Historical Society archive, catalog number illegible, filed under * miscellaneous mining curiosities. *. The loop itself was sent to the Academy of Natural Sciences in Philadelphia. The Academy acknowledged receipt. A curator noted it as * a gold alloy loop, Carboniferous coal matrix. * No analysis was published. The object does not appear in any subsequent catalog. The photograph in Pottsville is the only physical evidence that the Schuylkill chain ever existed. In March of 1903, a blasting crew in a coal mine in Kanawha County, West Virginia, opened a sealed pocket in a seam wall and found an object resting in a smooth cavity inside the coal. The foreman, a man named George Durst, extracted it carefully because he could see immediately that it was not stone. It was a chain 14 inches long. The finest of the 3 found so far. But what made it different was the pattern. The links alternated in size, a large oval, then a small round, then a large oval, repeating in a decorative sequence that was clearly intentional. This was not a functional chain. It was ornamental. It was designed to be seen. Durst brought it to a chemist in Charleston named Rufus Landon, who tested a small filing from one link using standard assay techniques. Landon presented his findings to the Kanawha County Scientific Society the following April. The metal was a gold alloy, containing iridium and osmium. Now stop and hold those 2 words. Iridium and osmium are platinum group metals. They occur in nature, but not alloyed with gold in any known natural deposit. And producing a gold-iridium alloy requires sustaining temperatures above 2,400 degrees Celsius. Roughly 1,000 degrees beyond the capacity of any forge or furnace available in 1903. Or in 1803. Or in any century before the development of the electric arc furnace in the early 20th century. Landon knew what he was looking at. He asked the Smithsonian to conduct a more detailed analysis. The Smithsonian acknowledged his letter. No analysis was published. Landon kept the chain in his home laboratory until his death in 1921. His estate records list his scientific instruments and specimens. The chain is not among them. Here is what we have so far. 4 chains. 4 states. Spanning 35 years. Each found by a different person doing ordinary work on an ordinary day. Each one sent to an institution. Each one gone. The Wilkes-Barre chain, logged at Lehigh, vanished. The Schuylkill loop, received by the Academy of Natural Sciences, vanished. The Kanawha chain, tested, confirmed impossible alloy, Smithsonian contacted, vanished. The Morrisonville chain, 9 lines in a small-town paper, current location unknown. Before we get to the 2 chains that were tested and confirmed the same alloy 34 years apart, make sure you're subscribed. Because the 5th chain on this list is the one that has never been tested, is still sitting in a building with a street address, in a drawer with a number. And if its alloy matches the others, the number changes from 2 to 3. And 3 is no longer an anomaly. 3 is a manufacturing signature. In 1914, a miner named Josiah Combs was working an expansion gallery at 800 feet in a coal mine in Harlan County, Kentucky. His pick struck something that rang. Not the dull thud of rock against metal. A clear tone, the sound of a dense object receiving a sharp blow. He cleared the coal around it with his hands. What he pulled out was a chain, short, 5 inches, and heavy. The links thick and load-bearing, more like a fastening chain than jewelry. But closed and seamless, the same as every chain on this list. Combs did not send it to a university. He did not contact a scientific society. He cleaned it, ran a leather cord through it, and wore it as a watch fob for the next 20 years. His daughter inherited it. His granddaughter donated it to the Southeast Kentucky Regional Museum in 1967, along with a handwritten note explaining where it had come from. The museum accepted it, recorded the provenance, and placed it in storage. It has never been displayed. A museum volunteer who handled the donation in the 1990s told a local historian that the chain sat in a drawer marked coal mine artifacts, beside a collection of carbide lamp parts and a miner's lunch pail. Nobody had tested it. Nobody had photographed it. Nobody had looked at it since the day it went into the drawer. Asterisk drawer 14. Building B asterisk. On a shelf beside a dead man's lunch pail. The most accessible piece of evidence on this list. The one with a specific location, a specific building, a specific drawer number. And the one that has received the least attention of any of the 6. The last chain was found in Indiana, in a seam of lignite rather than anthracite. Lignite is younger coal, tertiary rather than carboniferous, roughly 50 million years old instead of 300 million. The find was made in 1937 by a power plant worker named Harold Moss at a generating station near Clinton, in Vermilion County. Moss was shoveling fuel from a delivery pile when he noticed a glint in a cracked lump. He broke it open. Inside was the most delicate chain of the 6. 9 inches long. Each link slightly different from the last, not uniform like the Wilkes-Barre chain, not patterned like the Kanawha chain, but individually shaped, as though each ring had been formed by hand rather than by a repeating process. The effect was filigree. The chain looked like lace made of metal. Moss brought it to a metallurgist at Indiana State Teachers College in Terre Haute. The metallurgist, Dr. Francis Howell, tested a small sample and found the same thing Rufus Landon had found in West Virginia 34 years earlier. Gold. Iridium. Osmium. The same elements. The same ratio. 2 chains. 2 states. 2 different geological ages of coal, one 300 million years old, one 50 million. And the same alloy that no natural process produces and no laboratory before the 20th century could have created. Howell wrote a letter to a colleague at Purdue describing the result. He noted the coincidence. He did not publish. He did not contact the Smithsonian. By 1937, he had apparently heard enough about what happened when anomalous objects were sent to institutions. The letter survives in the Purdue University archives. The chain was returned to Moss, who kept it in a cigar box in his garage. His family has not been located. The institutional response across all 6 cases followed a pattern so consistent it reads like a policy. Asterisk acknowledge the object if forced. Decline to test if possible. If tested, do not publish. If published, do not cite. If cited, do not follow up. Asterisk. Let the object disappear into a collection, a drawer, a cigar box, an estate sale. And wait. The Academy of Natural Sciences received 2 impossible objects from the same county 32 years apart. It lost both. The Smithsonian was contacted twice about gold alloy chains in Carboniferous coal. It responded twice with silence. Lehigh University logged a chain and then could not account for it. A museum in Kentucky accepted a chain with full provenance documentation and filed it beside lamp parts. The strategy was never to disprove. Disproving would require engagement, and engagement would put the object on record in a way that could not be undone. The strategy was to not look. To classify without examining. To receive without testing. To store without displaying. For 130 years, it worked. Because the 6 chains were scattered across 6 different states in 6 different archives, and no one had ever lined them up and looked at them together. Here is what the record actually shows. The Morrisonville Times for June 11, 1891 is on file. The Schuylkill photograph is in the County Historical Society. Landon's report to the Kanawha County Scientific Society exists in the Society's Minute Book. Howell's letter is in the Purdue archives. The Harlan specimen is in Drawer 14, Building B, at a regional museum in southeastern Kentucky. Every one of these finds left a paper trail. Each trail was designed to be the end of the story: 9 lines in a small-town paper, a photograph filed under miscellaneous, a minute book nobody reads, a letter between colleagues never published, a donation slip for an object never displayed. Small enough to ignore. Scattered enough to never intersect. But paper does not forget. Archives do not decide what matters. They hold everything, and they hold it until someone walks in and asks the right question. The right question is not whether the chains are real. The newspaper confirms one. The photograph confirms another. 2 independent chemical analyses confirm the same impossible alloy in 2 more. The museum drawer confirms a 5th. The right question is this. Is anyone going to test the Harlan specimen? The one sitting in a building with a street address. In a drawer with a number. Accessible to anyone with credentials and a spectrometer. Because if the alloy matches, If the gold-iridium-osmium ratio in that drawer in Kentucky is the same ratio that Landon found in West Virginia and Howell found in Indiana, then the number is no longer 2. It is 3. And 3 identical alloys in 3 different states in deposits of 3 different geological ages is not an anomaly. It is a manufacturing signature. 6 chains. 2 tested. 1 accessible. The question of what is in drawer 14 has a very simple answer. Nobody has chosen to find it yet.